Hey, hi everyone. Welcome back to this another beautiful session, and we will be continuing our Java only, and we won't waste a lot of time. Let us get started. So yeah, so we are getting started with the operators now, and there are three types of operator. So in past session, in the previous session, we learnt about variables. I told you about that fridge lunchbox concept, and you can always visualize it, and you will be good to go. Now in operator, there are three types of operators, and okay, so yeah, so there are three types of operator. First is arithmetic operators. This is not something of a language specific thing. Like you will find arithmetic operator in all the languages. This is a concept. It's a mathematical concept. Then there are relational operators, and then there are logical operators. And yeah, pretty much these are the three type of operator. We can broadly classify our operators into three sections. Now let us get started with the first one. So yeah, arithmetic operator. You might be understanding what is arithmetic operators. Yeah. So arithmetic operators are those operator plus, minus, addition, subtraction, divide, and then there is a multiplication. And there was another operator which we saw in the previous video, that was a modulus operator. So in languages, in programming languages, if I talk about Java, so this gives us the quotient. Like if you do this 4 divided by 3, this will give you 1. Okay, or if you do 7 divided by 3, this will give you 2. If you do 7 modulus 3, this will give you what? 1. So how does it work is, this is 7, this is 3, 3 2 goes 6, and I do the minus, and this is 1. So this is what the divide operator returns us. I will put a quote here, and this is what modulus operator returns us. Yeah, arithmetic operators are easy. If we will quickly jump. I'll open the key repo, and I'll push everything today because yeah, I guess the syllabus is very good. Yeah, so I'll make this big. I'll go to cd dot, I'll do ls, I'll make another directory mkdir 00 003. Yeah, I'll go to cd 003, and I'll make touch arithmetic dot java, METIC dot java. Yeah, so we have arithmetic.java, and we'll quickly see if it is working or not. We'll make a class arith, and we'll do public static void main string. Bear with the syntax again, and it'll print system dot out dot print arithmetic operation in Java. Yeah. So again, we have to compile the code java c aridhmetic, or like what should we do? Let us do array, because we'll compile this like this. Array.java we can do, otherwise we have to write such a big name. And now we can do Java, and we can do, I can take this name and I can do this. Yeah, this works. Now so this is the byte code. Now let us talk about operators. So I can do int num1 equal to 10, and I can do int num2 equal to 40, and now I can do int num3, or sum is num1 plus num2. Yeah, this is okay, and I can just quickly print this out, and I'll just compile the code, or what we can do, we will have a shortcut. I can do java array dot java. Yeah, so this is working. We get 50 here. Yeah, so this is working, and you can do it like this only. You can try difference, or you can try multiplication, or you can try modulus. Yeah, so works. Everything is working, and it's easy. It's really easy. If you can see, 10 modulus uh, 10 modulus 40 modulus 10 is 0, so that's why we got 0 here. And yeah, this is pretty easy. These are the arithmetic operators. These are very easy operators. And now I have to teach you one thing more, that is increment operators. Now, what are increment operators? I'll just quickly remove all this. And now, if you want, you can do int num2 equal to num1 plus 10. Yeah, I'm increasing the number. Or what I can do, I can just do num1 equal to num1 plus 10. What it's gonna give me, I'll just do system.out.print to see what does it gives me. Just to be on top, I removed. It shows num1 is already defined, so I cannot define it again. So what I can do, I can remove this. And yeah, and I can do java, so it gives me 20. Now, so I am incrementing num1 by 10, and then assigning that value that is getting returned to num1 again. So 10 plus num1 was 10, this goes 20, and I assigned it to num1, so num1 goes 20, and I'm throwing an output. Now there can be a case where I can do num plus num1 equal to num1 plus 1. I can do this, but yeah, so it will give me 11. No, not 11, it goes 20, and then it goes 21. If I remove this will give me 11. Yeah, it gives me 11. Now, just to let you know, there is a syntax that we can do, that is, if I am incrementing the same number and assigning it to the same number, like if I want to increment num1 and assign it to num1, so there is a syntax name plus equal to. So this will do the same job as I'll do this. This will do the same job, same as this. And if we try to do this, we get 11. Now I can do it by 20 probably. Like I can make this number 20. I can increase it by 10. And you can do this in any arithmetic operator, like num1 equal to minus 5, multiply and divide, and yeah, this all will work. Yeah, why it did not? Okay, I have not saved it. Okay, so it is trying all the arithmetic operation, and then this output is coming. So you can try this, and this will work. Now that is okay. Now there is one thing more, that is known as this is okay. We can remove this. Now I can do self increment as well. I can do num1 plus plus. What it's gonna do? It is equivalent to num1 equal to num1 plus 1. This is num1 plus plus. So it should give me 11. It gave me 11. That is num1 plus plus. There is something plus plus num1. It will again give me, so I can remove this, and it will give me again 11. You might be thinking why Java is playing with us. Like, it could have just given us num1 plus plus and things would have been better. Why they wanted to give a plus plus num1? Now here comes the part. So this is a self increment operator only. So we did, so this is self increment operator. So there are two things I did. So there was a pre increment then there is a post increment. Now what is pre and what is post? When I was doing plus of num1, that is pre increment, and if I do num1 plus this is post increment. Now what does it mean and how they are different? And if I can show you, I can show it right now. So what I'll do, I'll remove this, I'll print this. What it should give me? It should technically give me 11. I do it, it gives me 10. Why? And if I do plus num1, it should give me 11. It's giving me 11. How does it work? When I chipped in plus num1, so how does it work is, when there is a pre-increment operator, so what it's gonna do, first it's gonna increment the value, and then this statement will get executed, then this will get executed. So what happened, I did system.out.print, and there is plus num1, so it incremented it. It saw here there is a plus number, it incremented it, and then we got the print. So that's why we got 11. Now for the post increment, it will execute the statement, and after this, like it will execute the statement like system.out.print num1, that is 10, it will execute it, and after the execution of it, the num will get increased. So it will give me 10 because the current value is 11, but at the time of printing, when this statement was getting executed, when it was at this line, the value of num1 was 10, so that's why it got printed 10. Now if you want to really check was it incremented or not, I can add up a num1 again. See, it got 11, so this got executed, num1 was 10, it got printed 10, then the value got incremented, that goes to 11, and then I got this. So this is a post increment operator, and it's a very beautiful concept. Like it gets incremented after after the statement is executed, and in pre-increment it increment first and then the statement gets executed. So this is a pre-increment and post-increment operator. So arithmetic operators are like this only. They are easy. They are really easy. Also, these are also known as urinary operator, because there is same unary sign included. That's why they are also known as urinary operator. But yeah, you don't have to play with the words jargon. You should know the concept. It's a very beautiful concept. Yeah. So pre-increment, post-increment is done, and we got modulus, we got multiply, divide, and yeah, this is great. Now we can go with the relational operator, and like it's clear by name what is a relational operator. Relational operator is something related to relation. What's a relation? Like you are connected to me, that's a relation. But in computers, relation doesn't work like that. Relation is different. What's the relation? I can tell is 10 less than 5. It's a relation. Yes, it's true. And is 10 less than equal to 10? It's true. Can I do 10 greater than equal to 10? Is it true? Can I do 10 less than 10? Is it true? No. Let us examine all this. Is this statement true? No, it's not. It's false. Is this statement true? Yeah, it's true. Is this statement true? Yeah, it's true. Is this statement true? No, it's not. It's not. This is a relation. This is a relational operator. And so this is not a concept of coding. This is a mathematical concept. And you know what? They see this relational operator. Wait. Yeah. So relation operator is this simple, and also there is this very beautiful beauty of relational operator. They throw a boolean value. They'll always throw a boolean value. Keep this in mind. What's a boolean value? It's a true or a false. Boolean in Java is not 0 and 1. We talked about it in the previous session when we were talking about data types. Boolean in Java is simply true or false. So whenever you do any type of comparison, it's gonna throw me a boolean value, and we can try out this as well. Let me see. Yeah, so there is num1, and let us take num2 int num2 20, and I can do so let me chip in a heading relational operators, and I will take a boolean value first, boolean, and I'll do is num1 is num1 greater than num2. So I'll do simply a system dot out dot println is number greater than num2, and I'll hit it. Shows false. Why? Because is 10 greater than 20? No, it's not. If I do 10 is greater than 10, what it should give me? I'll come on top again, and it will still show false. Why? Because 10 is not greater than 10. Is 10 greater than equal to 10? Yeah, it is true. And I can play with anything, like I can play with any type of jargon. So we got to know there is something known as less than equal to. Less than. I got to know there is something known as greater than. I got to know there is something known as less than equal to. I got to know there is something known as greater than equal to. And this is simple maths. And there is one condition more, and that is the most important condition. You're going to use it a lot in your program when you're going to make very good APIs. That is comparison operator. This one, equal to. Now in Java, what happens if you do int a equal to 10? This is an assignment operator, so I cannot use a single equal to here, because this Java will understand it as an assignment operator. So if you want to compare, is this number equal to this, you cannot do this, you have to do equal to, so that Java understand it's a comparison operator. And for real, this is actually a very important operator. You will see it in almost every language. This comparison operator is the one which is mostly used. So I can try. I can do equal to. Is it true or false? It's true. It is true. If I do 10 equal to 20, is it true or false? It's a false. Yeah, it's a false. So yeah, I don't know why I kept this, but yeah, I hope you understood this concept. So we have 5 operators here. There is a less than, there is a greater than, there is a less than equal to, there is a greater than equal to, and then there is a comparison operator. This is the most important operator, and it's easy. It's very easy. And yeah, that is all about relational operator. Relational operator are relatively very easy, and the equal to one will be used the maximum. I'll just check is recording is working. Yeah, it is working. Now let us see the third operator. That is the logical operator. Now think of this logical operator. Now you must be thinking, what is a logical operator? Like, we got to know about there is something known as arithmetic operator, basic arithmetic, and then there is something known as relational operator that talks about relation. And what is logical operator? It talks something about logic. So let us take an example. So I want that let's suppose I want all the people from a database who are male and whose age is greater than 40. So I can check gender equal to male. Okay, that is a relational operator. and I checked age greater than 40. Just a second. Yeah. Yeah. So sorry, I hit it up on the silent. Yeah. So I want gender to be male and all the users whose age is greater than 40. This is a different relational operator. This is another different relational operator. How do I club it? Like I want the intersection of both of this. I do a and. This is an and. What's it's gonna do? It's gonna check this and this, and if both of these are true, it will return it to me. So there are three type of operator, three type of logical operator. First of all, let us talk about two. Then we'll talk about another one. First, there is an and operator. This is really not Java or programming. This is really mathematical concepts. And then there is an or operator, and then there is a not operator, and there is another operator. We won't talk about it right now, but we will definitely see it, and we will see the use case of it. And in an upcoming project, I'll show you how to actually use that particular operator. So yeah, now for the and operator, the sign is and. So this is an and sign. Yeah. For the or operator, it's a pipe, and for the not operator, it's a exclamation mark. What does and do? And gonna check is statement 1 is true and statement 2 is true. If these both are true, then it will return a true statement. If any of them get false or both of them get false, it's gonna throw me a false. It's gonna throw me a false. If this is false, this is true, this is gonna throw me a false. If this is true and if this is false, it's gonna again throw me a false. And if this is false and this is false again, this will again throw me a false. So for and to be true, both the statement should individually be true to get the output to be true. This is for and A and D. This is basic mathematics. So remember this table. It's a very beautiful table, and you'll get this in semiconductors, and you'll get this in science as well. You'll get this in math, and you'll get a similar table to this in probability. You'll get a similar table to this in permutation and combination, and yeah, I can throw this. And then there is a or operator. Now in or operator, you might have guessed it. There is a statement 1, there is a statement 2, and the condition for or statement is either one of them should be true, and if both are false, then only it's going to be a false. So if it's a true, I'm good to go. If it's a true, statement 2 is false, still I'm going to throw a true. If this is a false, this is a true, I'm going to throw a true again. T. It's not a false, it's a T. If this is false and this is false, then only I will throw a false. So for a statement in or operator to be false, both has to be necessary false. And for a statement to be true, both has to be true. Like if you understood this, it's very easy. And for and operator, it's just if you have a false, you do a not operator, it will throw me true. And if there is a true and you add a not operator again, it will throw me a false. So it just reverses the sign. That's all. This is very easy. Yeah, that is the theory of logical operators. Now I'll tell you a very beautiful concept of short circuiting. So what is a short circuiting? Short circuit. So in short circuiting, you have to take the simple twice. So this like and or, so this is like, this is a short circuiting concept. Now think of this what is short circuiting. I'll just, yeah. So let's suppose I have probably age, and age equal to, let us define more variables. Int num1 equal to 10, int num2 equal to 10 again, and I do, and we can do it 11, and I defined another two variables, that is int a, that is 15, int b, that is 20. Now what I do num1 is less than num2 and num and a is again less than b, and I can just try to reverse the sign. I can just copy this, and I can go here, and I can do or as well here. Now for it's gonna check. So how it's gonna check? So it will do num1. What is num1? 10 is less than 11. Yeah, this is true. And then it's gonna do a and then it's gonna see a, that is 15, is less than 10, is less than 20. Yeah, this is also true. So I can do it age 1 and age 2. So just to differentiate the variables, this both are true, and it's an and operator, so age gonna be a boolean and this gonna be a true. Now see this very beautiful concept. For age 2, this is 10, that is less than 11. Is it? Yeah, it is. Since there is a short circuit here, because this is a true, doesn't matter whatever here is, doesn't matter there is a true or a false, this will always return a true. So what's it's gonna do? It's not even gonna check the statement, it's gonna just assign true here, and vice versa. What if anywhere this tends to be false, it won't even check, it will just chip in false in age 1. I hope you understood this. So it skips it, it short circuits it, it takes a short path. So for and if the first statement is false, it's not gonna go to the second pass, it's gonna just assign the value. That's a short circuit. It goes like and if for the or operator the first value is true, it's not gonna check for the second value because it doesn't matter. So it's gonna short circuit again, it's gonna take a short path and it's gonna come here. That is about the concept of short circuiting, and it's a very beautiful concept, and we got logical operators as well. Now just a sec. Yeah, so we'll just check the logical operators here. So int a equal to 10, and not 10, let us do it 100 so that we know, and int b equal to 200. Yeah, works. Now I can talk about age. Maybe I can take boolean, not this. I don't know, boolean. I'll disable the auto suggestion in the next lecture. Boolean output. So we'll check if num1 is less than num2 and a is less than b, and I can just output it. And what's it's gonna throw us technically is 10 less than 20. Is yes, it is, this is true. Is 100 less than 200? Yes, it is true. It should throw me a true. Okay, so what is it? Okay, so there is a here, so I have to do b and c. We'll see what is a there. and I can do b less than c here, and now let us check. It shows me a true. Perfect. Now what I can do, I can take another boolean, like another boolean, and I can check this condition, and I can do this, and it is throwing me true. Why? Is num1 greater than num2? No, it's not. It went to the other side. What it did is b less than c. Yes, it is. False or true gives me a true. That is why it is shown true. If this was true, doesn't matter what was here, true or false, I would have got a result as true only. It would not have checked. Yeah, pretty much. And that is there. So yeah, the session goes a little to the logical side, but yeah, this was required to be understood. And what I can do, this is throwing true right now. I'll just clear so that I come on top. There is a true. I can just add up a not operator. It should throw a false. It is throwing a false. Can I do double and double not? No. Okay, so we can do double not. Okay, I got to know about this. So double not gives me not and not. And can I do three nots? Yeah, we can. So yeah, this goes like this. Perfect. So I never had a use case where I have to do double not, and it doesn't even make sense as well. Not and not. So not and not goes to the same value. Yeah, pretty much. And yeah, that is all. And we'll just quickly revise here. So we have three type of operator: arithmetic, relational, and logical operator. What are arithmetic operator? Used for arithmetic operations, addition, subtraction, divide, multiply. And then there is a modulus operator. We got to know about what is modulus operator, and we know what's the difference. And also, just to make you all understand this, we can check the relational operators for floats as well, or for doubles as well. So the OU BLE, let us do 10.10, and we can do double 20.20, and I can do double output, and I can check. This is not going to be double, this is going to be boolean, and then I can do output. What it should throw me? It should throw me a true. Yeah, it is throwing a true. So I can do the arithmetic operator or relational operator on double and like on any sort of data types. So yeah, we got these things. Then there was a concept of pre and post. So pre-increment operator. So then there is a post or increment operator. We got to know about what's the difference, how the position of a plus plus is defining the values, and there are very beautiful use cases of it, and we will learn this in later sections. And these are also known as urinary operator. This is just another jargon. And then we have relational operator. Relational operator plays around with the relations, and we have like 5 type of relational operator: less than, greater than, less than equal to, greater than equal to, and then there is a equal to. This is a very beautiful operator. This is very important operator, to be precise. And yeah, we coded this as well. And yeah, and then we learnt about logical operators. Logical operators are the one who plays with the logic, obviously with the word, and we got to know about how this worked. And we got to know that these tables, these are important, and you might have seen this in your mathematics somewhere. So for and, both should be true. For or, either one should be true. And then we got to know about what is short circuiting, how we can do how we can short circuit. So we coded this as well. And yeah, that is really all for the operators. And yeah, that is all in this section. I hope you really liked it. I know the session duration is getting extended, but yeah, the session will be around 40 minutes only. And yeah, I hope everything is good. If you have any sort of doubt, you can hit the comment section, as well as we're going to be starting with if else conditions, and in the next section. And then we'll get started with loops, and then we will get started with object classes and arrays. And that's how we will be ending our core Java. We will play around with quite a few things as well, and we'll do lambda expression and all as well in this module only. And yeah, pretty much it. I hope you really like this session, and I'll catch you all in the next session. Thank you.